Alright guys, here we go. We're going to talk about what happens when two or more forces are interacting with one another. So this is what we did in class on Thursday. Here's our man, the myth, the legend, Isaac Newton. The first problem, this is problem number 1 on the worksheet that I passed out in class on Thursday. It's called practice problems on top for Newton's third law. So we have a truck towing a car. We're given the mass of the truck, it's 4,000 kilograms. We're given the mass of the car, it's 1,600 kilograms. And we are given the force of the truck, the force of the engine moving the truck towards the right, 2.5 times 10 to the 4th newtons. We want to know the acceleration of the cars, because, the acceleration of the car and the truck are going to be identical because one is towing the other. And we also want to know the force of the tension between the car and the truck. So what are we going to do? Well, the first step is to draw a free body diagram for the entire system, the car and the truck together. That will help us find the acceleration because the acceleration is the same for both the car and the truck. So we need to draw a free body diagram for the entire system, the car and the truck together. The normal force is up, the force of gravity is down, but we're really concerned about the x direction. So we have a force applied by the truck to the right. Let me stop there for a minute. The reason why there's no friction is because in this particular problem we are going to ignore friction for the sake of simplicity. So after we've drawn our free body diagram, the next step is to write out our equation, Newton's second law, F equals ma. We only have one force. That is the force of the truck. That's given, 2.5 times 10 to the 4th newtons, equals the mass. Now this is the entire system, so I'm taking the mass of the car plus the mass of the truck together, times acceleration. So this is the expanded form of F equals ma. We have the net force on the left side of the equation because there's really only one force in the x direction. And then on the right side of the equation, I have my combined masses of the car and the truck times acceleration, which is the unknown. We can solve for acceleration, and there's our answer. Okay? Now the next step is to solve for the tension between the truck and the car. So now we need to draw a separate free body diagram for just the truck. The reason why we need to draw a second free body diagram for the truck only is because we're looking for the tension between the truck and the car. So we have to separate them somehow because the tension is unique to the different systems in the problem. So I'm writing out our expanded equation here of Newton's second law. I'm sorry, that should be times A. We have our sum of the forces on the left, the force of the truck minus the force of tension. So that's the net force equals the mass of the truck, because we're doing the truck only, times the acceleration of the truck only. So this is Newton's second law written out, expanded. So we can plug in for the force of the truck, which is given, the force of tension is unknown, equals mass times acceleration. The mass of the truck only times the acceleration of the truck only, which we've already found. And then we can solve for the force of tension between the truck and the car, and we get 7,160 newtons. All right? Keep in mind, this is the truck. This is Newton's second law written out for the truck only, because in order to find an isolated piece of the system, we need to divide it up into its individual components. Let's take a look at another example. This is the second problem on that same worksheet. We have two hanging masses in an elevator. The mass of the top block is 14.2 kilograms. The mass of the bottom block is 10.4 kilograms, and we are accelerating upwards. So again, we're in an elevator. We have hanging masses. We are accelerating upwards. The acceleration is given. We're also given the mass of the blocks. The question is, what is the tension in the top cable, and also what is the tension in the bottom cable? Let's first just focus on that top cable. So we're trying to find the tension in cable 1. So again, just like the previous problem, we're going to draw a free body diagram for the entire system, not just mass 1, not just mass 2, the whole thing. So we have two forces acting. In the upwards direction, we have tension 1, because the tension 1 is holding both of those masses up. And then in the downwards direction, we have the force of gravity, because that's the only force acting on the system as a whole in the downwards direction. So we can set up Newton's. Okay, so I'm writing out the force of gravity here. It's the combined masses times g. So now let's write out Newton's second law expanded. The sum of the forces is equal to mass times acceleration. So the sum of the forces is the force of tension 1 minus the force of gravity. That's the net force, equals mass times acceleration. And keep in mind, we're talking about the mass of the entire system, the acceleration of the entire system. We're treating both blocks as one unit at this point. So let's plug in. Force of tension 1 is unknown. The force of gravity is shown as above, mass times g, and then equals the combined masses times the acceleration. And then we can solve for force tension 1, and we get 311 newtons. Okay, now the second question is, what is the force in cable 2? So in order to find the force in cable 2, we need to divide our system into its individual components, because we just want that force in tension 2. So now I'm going to go ahead and draw a free body diagram for just the first box, just the 14.2 kilogram box. I could just as easily do it for the second box and solve, and you would get the same answer for the tension in cable 2. I'm just going to choose to do a free body diagram and solve for the box on top. So here we go. In the force in the upwards direction, we have the force of T1. We're just talking about that 14.2 kilogram box right there. The force going up is the force in tension 1. Force going down is the force of gravity just on that box, just on the top box. And then also we have the tension 2 in the downwards direction as well. So if I set up my net forces here, I have force of tension 1 minus force of gravity minus the force of tension 2 equals ma. So this is Newton's second law expanded. The sum of the forces on the left side of the equation equals mass times acceleration. I'm sorry, I should have written that as F sub T2. Okay, here we go. We plug in our numbers. We already know all that. We're solving for the force of T2 equals mass times acceleration. Now keep in mind, I'm just writing the mass of the top block. Not both of them, just the top, because we're solving for the individual components here. If we put it all together, we find that the force in tension in cable 2 is 131 newtons. Now, if you were in class on Thursday, what I forgot to do was include the force of gravity of the top block in this equation. For the sum of my forces, I only included the force of tension minus the force of the other tension. I did F sub T1 minus F sub T2 equals ma. I forgot to include the force of gravity, because the force of gravity is also acting on that top block. All right, there's your answer.